This week on Office Hours, we're at the Chicago Field Museum. I'm here with Corrie Moreau in the Chicago Field Museum. Corrie, what do you do?
So I'm an evolutionary biologist and I'm an associate curator professor here at the museum.
So you've worked with David Hughes.
Yeah, so David and I have been friends and colleagues for a long time. David, I think you're awesome. We've done some really... So the work that we do is actually looking at the evolution of this parasitism. So as you know, David's work is really focused on the zombie ant system. And so my research is really focused on ant evolution and on the impact of microbes on the evolution of hosts. And so in the collaboration with David, what we're trying to understand is how often has zombie parasitism popped up across the ants? So are there hot spots or cold spots in the ant tree of life? So are you highly susceptible in some parts of the sort of family tree of ants and are other parts just non-susceptible? We can sort of map that on the big ant family tree to understand how many times have these things arisen. So that's the kind of work I've been doing with David.
And you were the one who created the ant family tree, weren't you?
Yes. I don't know if I could say single-handedly. I had some great collaborators along the way, but yeah, that was some of my dissertation work.
How many species of ants are there across the world?
So there are about 13,000 species of ants that have names given by scientists, but we know that that number is at least double, if not triple. And so to put that in perspective, there are more ants than all the birds and mammals added together.
Wow. And they live on all 7 continents?
So you can find ants on all the continents except Antarctica, which is the only one that has a great name for ants, right? Now, if we were to sort of go back in time and think about the configuration of the continents during, much more ancient times, ants were likely found also on that continent.
Cool. And what are some of the things that allow ants to be so widespread?
One of the things that's really interesting about ants is that they can almost occupy any niche. And whether that's the environment in which they're found, so you find ants in the driest of deserts, you find them in the wettest of rainforests, you find them from the tops of the canopies down to underneath the soil. That's one of the things that I think makes ants highly successful. The other aspect of that is that ants have the ability to acquire new diets. And so as you move into these new environments, you have to be able to take advantage of the resources there. So in the case of desert ants, sometimes they'll harvest seeds, right? So they'll grind seeds up and feed on those primarily. Or in the case of ants that have moved up into the canopy, and many times that they've essentially shifted from a predatory diet to an entirely herbivorous or vegetarian diet. And the way that they've been able to do that is by acquiring gut microbes that upregulate their diet. But what we've tried to understand are factors that might be related. So we've studied things like how often has, increases in colony size evolved across the ants? Where do we see lineages increasing in their diversity? And what does it correlate with? So it might be things like defensive characters. So with one of my graduate students, we've been looking at the evolution of defensive characters across the ants, and are there essentially trade-offs in how you invest in defense within a single species. So whether you invest in things like spines or in a sting, or whether it's in having a really large colony size or being polymorphic. So how do you defend your nest?
Does that really depend on the environment that they're in? Do you see certain defenses in harsher climates?
Actually, what we see is that almost all of those characters arise in almost all potential environments. So it doesn't seem to be that the environment in which they're embedded is what's driving that. It seems to be probably the interaction. So either what's predating on them or where there's competition among different species of ants.
Also, ants are relatively small. What allows them to be so successful defensively?
They live in these social systems, right? So unlike, other kinds of invertebrates or insects where you run into one, and even if it's heavily defended and it has spines, you really only have to sort of get around that one. Where in ants, because they live in these large, complex, systems, if you disturb one, you know that soon you're going to disturb lots, right? And so it's a power of numbers. So it's not only having individual defense, but also having a colony level defense that sort of has helped facilitate their sort of ecological success. It's why they can capitalize on new food sources.
How long have ants been around?
The fossil record goes back to about 100 million years. But one of the tools that we can use is we can sort of take molecular and genetic and genomic tools and infer relationships, and then use those fossils to help us date when those lineages arose. So essentially the fossils act as minimum dates for when a lineage happened to be on the planet. So with the case of ants, we have actually hundreds and thousands of ant fossils that we can sort of strategically place across the ant phylogeny. When we do that, we reconstruct a date of about 140 million years for the modern ants. So they've been around on the planet for quite a long time.
Put that into comparison with like humans or another species, how much longer have
Oh my
ants been
goodness.
here?
I mean, humans haven't even been on the planet for 1 million years, right? And now we're talking about ants have been here for 140 million years. So ants were running around biting the ankles of dinosaurs.
That's a long time.